So welcome everyone. On the last one we have discussed about the flip-flops. We have a brief discussion about that. So today we are going to move further in that topic, and we are going to discuss about the counters further. So simply flip-flops can be connected if they are connected together to perform the counting operation. So such a ground of flip-flops is a counter simply. Okay. If they are connected together, if flip-flops are connected together, flip-flops are connected together, they can do that counting. Okay, how they are going to do that, we are going to discuss in few moments. So such a ground of flip-flops is simply a counter, which is the type of, you can say, finite state machines. Okay, we are not going into details about that. Now the counters are simply classified as in two categories. Okay, according to the way they are clocked. Okay, according to the way they are clocked. Okay, जिस तरह से क्लॉक पल्स उसमें दी जाएगी उस पर डिपेंड करता है कि विच टाइप ऑफ काउंटर्स आर देयर, एंड द टाइप्स आर सिंपली यू कैन से एसिंक्रोनस काउंटर, okay, and second is synchronous. Okay, so these are the two types of counters we are going to discuss about. In asynchronous counters, you can say they are commonly also called as ripple counters. इसमें होता यह सिंपली जो फर्स्ट फ्लिप फ्लॉप होता है, कई फ्लिप फ्लॉप्स होते हैं, ठीक है, उसमें जो जितना भी आपको डिजिट का चाहिए, जितने बिट का चाहिए, तो उतने ही फ्लिप फ्लॉप्स आपके होंगे, ठीक है. If 2 bits are there, 3 bits are there, then 3 flip flops. If 2 bits are there, 2 flip flops will be there. तो उसमें एसिंक्रोनस काउंटर में सिंपली होता यह है कि पहला जो फ्लिप फ्लॉप होता है उस पर तो क्लॉक पल्स प्रोवाइड की जाती है, मींस एक्सटर्नल क्लॉक पल्स. ओके, बट जो नेक्स्ट बिट फ्लिप फ्लॉप होता है उसमें हम फ्लिप फ्लॉप 0, 1, 2 अगर इस तरह से हम माने, दिस शुड बी द लीस्ट सिग्निफिकेंट बिट LSB सॉरी. सो इस पे इसका जो Q0 होगा, Q जो आएगा इसका, Q यहाँ आएगा, Q बार इसका ये आएगा. जो Q बार जो होता है इसका आउटपुट अगली क्लॉक पल्स पर एज एन इनपुट प्रोवाइड किया जाता है. लाइकवाइज इफ देयर इज अ 3 बिट, देन इसका Q0 का आउटपुट, Q1 का आउटपुट, सॉरी दिस इज अ 1 नंबर फ्लिप फ्लॉप, इसका आउटपुट इस पर एज अ क्लॉक पल्स प्रोवाइड किया जाएगा. तो इसमें एट अ टाइम वी आर नॉट गिविंग द सेम क्लॉक पल्स टू ईच फ्लिप फ्लॉप्स, तो उसमें सिंक्रोनाइजेशन नहीं होता है. ओके, सो दैट्स व्हाई this flip-flops or these counter are simply called as a asynchronous counter. Okay, but if you come to the synchronous counters, then in synchronous counters the clock input is connected to all of the flip-flops. सारे flip-flops पर clock pulse connected होती है, ठीक है, इस तरह से नहीं होता है उसमें. तो we have the clock pulse on each flip-flop. Okay, so that they are clocked simultaneously. वो simultaneously clock कर सकते हैं, इस वजह से उसको synchronous counters कहा जाता है. Okay, so let's move and we should discuss first of all about the asynchronous counters. Now your asynchronous counter can be defined like this. In this type of counters, flip-flops within the counter do not change states at exactly the same time, okay, because they do not have a common clock pulse. Okay, that's why these type of counters are simply known as asynchronous counters. Okay, so first of all let's discuss about 2-bit asynchronous binary counter. Now 2-bit asynchronous binary counter, we can draw it like, if it is 2-bit, then there must be the 2 flip-flops. Okay, so just draw it, one box for one flip-flop and second one for second flip-flop. Okay, so there must be the external pulse or the clock pulse will be given to the first flip flop. Let us consider this FF naught. Okay, and this should be considered as flip flop 1. All right, so these are the two flip flops. Output of the flip flops we have considered, since this we have considered as 0 and this as 1, so this should be Q0 and this should be Q1. all right, and the output coming out here, which should be Q0 bar, this should be Q0 bar and this should be Q1 bar. Okay, so the pulses you are giving, we are giving here 4 pulses. Okay, we should draw 4 pulses over here. These are the clock pulses. Okay, so the external pulses should be given on the first flip flop. So this should be D0. Okay, and this is connected to Q0, and we have already told you that in asynchronous counter, the output, that is Q0 bar, should be given as the clock pulse for the second flip flop. So this should be connected like this. Okay, so this should be the clock pulse. The output Q0 should be the clock pulse for the flip flop 1. Okay, and so in similar manner, D1 is connected to Q1 bar like this. Okay, so this is simply you can see that this is a simple diagram of the 2-bit asynchronous binary counter. Okay, now how it is working, let's proceed. Now from here you can see that since this is a positive edge triggered flip flops we have considered over here. Okay, so flip flop 0, this one, the first flip flop, changes the state at the positive edge going. This is the positive edge over here, you can see these are the clock pulses, and this should be the positive edge of each of the clock pulse, first clock pulse. Okay, so FF0 changes the state of the state at the positive edge, positive edge of the each clock pulse, means here, here, here and here. ठीक है, इन चारों positions पर ये अपनी position change करेगा. If it is 0, it will get 1. If it is 1, then it will get 0. Okay, but FF1 changes only when triggered by the positive edge of Q0 bar. Q0 bar का जो भी जो आपका आउटपुट आएगा, जो इससे पल्सेस आपको मिलेंगी, वो इस क्लॉक पल्स पे जवाब देंगे. So suppose it is like this. Okay, suppose it is like this. So what are the positive edge of these pulses? This should be the positive edge, this should be the positive edge, this should be the positive edge. Okay, so at these position your flip flop 1 will going to change the position. Okay, means it will become 0 to 1 or 1 or 0. Okay, so it will behave like this. Now you can see that we are getting a time delay in operation of both of these flip flops. So this time delay or this mismatch of time, or you can say that these two flip flops will never trigger simultaneously. So that's why this counter operation is asynchronous. Now let's draw the timing diagram of this 2-bit asynchronous binary counter. So first of all, let's draw clock pulses. Okay, clock pulses, we have given 4 clock pulses, so we can draw it like this. So these are the 4 inputs or the 4 clock pulses we are giving, 1, 2, 3 and 4. Okay, so what should be the output of this? Means first of all, let's consider what should be Q0. Okay, then we will consider Q0 bar. So these are the positive edge of the clock pulses. So at these position we will see. So let's consider Q0 is at a low. Okay, is reset. So when it get the clock pulse, first of all it will get set. Okay, now it's moving, and at the next positive triggered it will again get reset. Okay, it will move in the same position. Then again at the third clock pulse was given, the positive edge, it will be set. Okay, now like this, the output of Q naught will be like this. Okay, Q naught bar, Q naught bar, Q naught bar should be just opposite to that. Okay, if Q naught was reset, it will be set at that point. Okay, and it will change the position at this, it will move like this. Okay, it will move like this. So this is what we get Q naught. Okay, now this is Q naught, and we know that this is Q naught bar. Now this Q naught bar is behaving like a clock pulse for the flip flop 1. So this Q naught bar is going in this flip flop. So every positive edge of Q naught bar will trigger the flip flop 1. Okay, so how it will behave? How it will behave? Now where are the positive edges? Positive edges of Q naught bar is at this point. Okay, all right. Now if Q1 was reset, now Q1 will be, if it was reset, then at this point it will come in the reset position, then it will get triggered. Okay, and it will remain in the set position until it get the another triggering pulse. So at this point it will get the another triggering pulse and it will again become reset. So this Q naught bar will behave like a clock pulse for second flip flop, means FF1. Okay, now from this we can make a table in which we can show that this is the clock pulse. Okay, and the outputs, what are the outputs? Q naught and Q1. Okay, so initially both the Q naught and Q1 was in reset position 0 0. When first pulse was given at this position, you can see at this position first pulse was given, then Q naught become 1 and Q1 is still 0. Okay, then when the second pulse is given, Q naught become low and Q1 become high, 0 and 1. Okay, when third pulse was given, you can see Q naught become high and Q1 is also high, 1 1. Okay, and at the fourth position over here, Q naught is low and Q1 is also low. At fourth pulse both become low again, recycles. Okay, it again comes to its initial state. All right, so this is how your 2-bit asynchronous binary counter is working. Now in a similar manner we can draw the 3-bit asynchronous binary counter. 3-bit asynchronous binary counter. Now in a similar manner, what will be the diagram of 3-bit asynchronous binary counter? It will be like first flip flop, okay, second flip flop and third flip flop. All right, FF0, FF1, FF2. All right, this must be D0, this must be D1, this must be D2. Okay, here is a triangle, clock triangle, and here we are giving the external clock pulse over here. Okay, this is Q0 output, this is Q0 bar output, and this should be given as a clock pulse for FF1. Okay, and this D0 is connected over here. D1, sorry, first of all let's draw Q1 and Q1 bar. Okay, and this Q1 bar is given as a clock pulse for second means third flip flop, which is FF2. All right, and this is connected over here like this, and this is output Q2 and output Q2 bar. This is connected over here like this. Okay, so this is the simple 3-bit asynchronous binary counter. Let's draw the pulses. Let's draw 3-bit is there, so let's draw 8 pulses over here. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, since this is 3-bit, so 2 to the power 3, 8. Okay, at after 8 bits it will get recycles. Okay, again in the similar manner, what we will do? We will do simply, first of all, let's draw what is Q0. Okay, what is Q0? Now Q0 will be triggered as every positive edge. These are the positive edge of the clock pulses. Okay, this is a clock pulse and these are the positive edge of the clock pulses. Okay, so it was reset, it will become set. Okay, it will move like this, it will become reset over here. So in a similar manner we will get like this. Okay, so this is what? This is Q0. What will be Q0 bar? Q0 bar will be just opposite to that. Q0 bar will be opposite to that. Means Q0 bar. This will behave like a clock pulse for like this. Okay. All right. So this Q0 bar will behave like a clock pulse for FF1, second flip flop. Okay, so this is the positive edge, this is the positive edge, this is the positive edge, and this is the positive edge. So at these points we will get Q1 as the output. Okay, so it was reset, it will become set at this point. Again it will become reset at this point. Okay, it will behave like this. So this is how we are getting Q1. Okay, now let's draw Q1 bar, because Q1 bar, as you can see, Q1 bar is behaving like a clock pulse for flip flop 2. So Q1 bar should be high first, then low. Okay, like this. Okay, so what are the positive edges? This is the positive edge over here, this is the positive edge over here. Okay, for Q2, this positive edge will behave like a triggering. Okay, so at this point, as it was reset, it will become set over here, and again it will become reset at this point. So this is your Q2 as an output we are getting. Okay, so this is how your 3-bit asynchronous binary counter will work. Let's draw the truth table for this. Clock pulse. Okay, let's take Q2, Q1 and Q0 like this. Okay, so initially all these are 0 0 0. Okay, when first clock pulse was given, let's see, this was the first clock pulse. 1 2 3 4 5 6 7 and 8. Okay, when first clock pulse was given, Q0 become high, Q1 low, Q2 low. Okay, Q0 become high, Q1 low, Q2 low. Then at second clock pulse, let's see, second clock pulse, Q0 0, Q1 high 1, Q2 0. Okay, it will become 0 1 0. Okay, when third clock pulse was given, again let's see, Q0 become high. Okay, Q1 is also high and Q2 is low. Okay, means 0 1 1. When fourth pulse is given, let's see, when fourth pulse is given, Q0 become low, Q1 become low, Q2 become high. Okay, so Q2 become high, both are low. Then 5, 6, 7, 8. Fifth clock pulse was given. Fifth clock pulse was given. Q0 high, Q1 low, Q2 high. Okay, means 1, 0, 1. Again it will repeat the cycle as 1. This was 0, 1. This will become 1, 0. Then this will become 1, 1. And at 8th clock pulse, final clock pulse, you can see Q0 0, Q1 0, Q2 0. Okay, it will again come to its initial state 0, 0, 0, means recycles. Okay, so here you can see that how your 2-bit and the 3-bit asynchronous binary counters are working. Okay, so this is up till now in this lecture. Thank you. Thanks a lot.